Okay, the first measure of variability we are going to learn is the range. The range is pretty intuitive. It is just the difference between maximum and minimum, right? So, for example, in our example, like 10-year Treasury notes, maximum yield happened in February 1985. That was 11.91%. And the minimum within in our observations, the minimum was July 2020, right? That was the minimum yield in the middle of COVID, right? So then we define the variability. It shows that Treasury notes yield changes varies within this interval, right? So somewhere in between 11.9 and 0.53, okay? So that interval is the variation of the Treasury note, and we define the range as their difference. The length of the interval where the yield varies. So as a result, the range is 11.374. So 11.3. This is a range. As I said, it's the variation, how much it can vary within our observations. On the other hand, S&P 500 index maximum was 341 in December 1986, and minimum is minus 94% September 1987. So that's interesting. Within 10 months, the maximum and minimum happened. It went up and down, right? Super extreme volatility. Anyhow, so at most it could be 341 and at minimum minus 94. So that's the variation, maximum variation we can see in our data. So the range is 436%, right? So that is a very simple and intuitive way to describe the variation in our data, right? So graphically, visually, you can think it this way. So the maximum is here, minimum is there. So then the length is 11.347. This is Treasury notes range. But S&P 500 maximum was here, minimum was here. So their difference is much larger. So it clearly shows the difference in their variability. So S&P 500 varies much more than Treasury notes, which is simple and intuitive. So and the greater the range is, the greater volatility, the greater variation in data. The random variable varies more, which is obvious, and it is pretty simple and intuitive. But it has a critical problem. It is extremely sensitive to outliers, right? So out of 456 months we have in our data, only 2 months have 300% or more, right? These two observations were 1986 and 2020. So then, for example, what I'm saying here is, so suppose that I chose the observation periods from 1985 to 2022, but if I just happen to reduce the observation from 1990 to 2019, then these two outliers will be excluded from our data. So the range will be totally different. So it's the reason why range is this big is because of one extreme observation, right? This observation drags up all the maximum all the way up to here. So if I happen to exclude this observation, then the range will be very different. So that's why the range could be a big problem. Or you can put it this way. Say at this time the output was like, so the return was like 300 something. But if you happen to make a typo, instead of typing it as 300 something, if you typed it as 400 and something, then just because of one error, you are going to see like 500, like range of 500 something. So one error can screw up everything. That is a big problem, right? Right? Random errors happen in statistics. So we are going to refine this measure. That is interquartile range. Remember, we learned percentiles in the previous chapter. The idea is like, say, 1 percentile is the bottom 1% ranked observation, and 99 percentile is top 1% ranked observation. Like that, if we divide the data into 4 equal groups by their ranking, then 25 percentile is the cutoff of the first group, the smallest group. We call that first quartile, right? We cut at the first quartile, then the smallest 1/4 of the observations are grouped. And then the second quartile is 50 percentile, like exactly in the middle, right? We cut in the middle, which is second quartile, and then another cutoff point is 75 percentile. So that's the cutoff for the top 1/4 of the observations. So if there is a whole sample like this, we cut half, which is median or second quartile, and each half is also halved, like at first quartile and third quartile. So we divide sample into 4 groups, and then what we are going to do is, so I told you the problem of the range is we are going to extreme. We are taking the minimum and the maximum, but those numbers are determined by only one number, right? So instead of doing that so then the outliers may cause problems. So what we are going to do is we are going to delete bottom 25% and top 25% from our data, assuming that they are outliers, treating them as outliers, and instead we are using middle 50%. They are safer, right? If you see extreme observations, drop them from our data and use only the middle 50% observations, and now calculate the range from them. The maximum of the middle 50% observations and the minimum of the middle 50% observations, and their range is basically this one. The third quartile is the maximum of middle 50% observations, and first quartile is the bottom of the middle 50% observations. So we are dropping bottom 25%, top 25% observations, and then calculate the variation of the middle 50%. So then it is similar. Basically, it is a kind of range, but we are intentionally removing extreme values. So it is more robust, more stable against outliers. So it's intuitive. And so typically IQR, interquartile range, is it's not much used, but in research we use this when there are a lot of outliers. Especially financial market is an example where interquartile range is used for analytic reasons. Like theoretically, variance may not exist. There is a like theory assuming that financial returns have infinite variance, and then we cannot calculate the variance. Then instead of the variance, we use interquartile range, right? So the idea is so based on this idea, like think about a treasury note. Then if you cut treasury notes yield into 4 blocks, then you have to cut here and there. These two numbers contain 50% of the observations. So 50% of observations are within these two numbers. So their difference is the variation of them is 4.049. That is interquartile range of Treasury note. And S&P 500 should be also trimmed. Trim out extreme 25% from the bottom and the top. Then the middle 50% are milder. They are less extreme, but still quite a lot of variation. So by the way, compare these numbers. The maximum was 300 and minimum was minus 94. But top 25% is only 52% relative to 340 something. And bottom 25% is minus 18 relative to minus 94. So that much observations are trimmed out. And then these middle 50% variation is only 71, right? It was 400 something, but after deleting outliers, the middle 50% variation is only 71. Visually, this is what we are doing. We cut like here, so then this much is top 25%. And bottom 25% is cutoff is here, so these are bottom 25%. And those observations are 50% of the total sample size, right? Within that band, middle band, 50% of observations live there. And this range, this distance is the interquartile range. Similarly, S&P 500, it is hard to see what is going on, but the middle band is much narrower than you expect, right? That's because there are super extreme outliers, right? These outliers are much far from the center, middle 50%, so that's why they are called outliers. So after deleting those outliers, in the end, the middle 50% variation is narrower than you'd imagine. Still, it's pretty wide, like more than 50% point. Okay, that was the basic idea. I'm going to keep it simple. Range and interquartile range are measures of variability utilizing percentiles. Idea is clear, but and their advantage is clear. They are stable against outliers. So what I recommend here is most popular, the basic, most common measures are, as you know, the mean and the standard deviation. Maybe you may know them already, but when there are outliers, you may want to use median or interquartile range. So these are alternatives to mean and standard deviation, but I'm just telling you first. And from now on, in the next video, I will define and explain what is the standard deviation. First, the variance, and then standard deviation. I believe you must have heard about that, heard about those measures, but we are going to define and we'll study some properties. Okay, so thank you for watching and see you in the next video.